14.2 is about circles. What in the heck does circles have to do with parabolas? Let's find out. A circle is a set of points that are in all directions of a given point, which is called the center. The common distance between points of a circle and the center of the circle is called the radius of the circle. We also use the word radius to describe any segment connected to the center of the circle to a point on the circle. In the figure to the right, A is the center, and a segment connecting A and B is called the radius. In this section, we're going to investigate equations whose graphs are circles. Ooh. You guys have any thoughts about that? Any thoughts about what an equation would look like that would create a circle on a graph? Any guesses about what an equation would look like if as a graph it looks like a circle? Let me try. In the graph, it's going to look like a circle. What would the equation have to look like? So parabola kind of has some of the traits of a circle, the end where the vertex is, right? But it's not a perfect circle, and the other end of it goes to infinity. Any ideas on what an equation would have to look like for it to look like a circle? Well, let's start with this example. This first example says, graph several points that are 4 units away from the point 2, -3. All right, well, can we put coordinate points on here? That would be really nice. Yes, we can. Okay, so what if, beautiful. Okay, so what would be the coordinates of a point that is 4 units away from this exact point? What is one of the options that I could use? Whoa, that's not going to work. Let's try that again. Whoop. So the easiest ways to move would be vertical and horizontal, right? So what's another coordinate that I could put on this graph that would be 4 units away from the 2, -3? You could add 4 to the x. You could subtract 4 from the x. You could add 4 to the y.
6, -3.
6, -3. Okay. And the distance between 2 and 6 is 4. Good. So you can add 4 to the x. You could also subtract 4 from the x, and then you would have -2, -3. All right, what if the changes I make are to the y? I'm still going to want to use the same difference though, right? So 4. So then the 2 is going to stay the same, but the 3 is going to have a +4, which would be 1. And 4 in the other direction would be what? Mia? So I added 4 to -3 and I got +1. What happens if I subtract 4 from -3?
-7.
Beautiful. Okay, so here are 5 points. We created multiple points around that point. What shape consists of all the points that are 4 units away? A circle. Suppose the point xy is 4 units away from 2, -3. Use the distance formula to write an equation involving both x and y. You guys know the distance formula already? Or are they just tricking us, acting like we're supposed to know this when we don't? Hello. Are you guys familiar with that? You ever heard of it? Nia, do you remember us ever going over the distance formula? Because you've been here since the very beginning. So I'm kind of surprised that it just mentions the distance formula.
Is that one with speed and time?
No, it's not. So the distance formula is a formula that derives from actually the Pythagorean theorem. So the distance formula is it derives from the Pythagorean theorem because if there are 2 points on the coordinate plane and I want to find the distance between them, I can draw a right triangle between those 2 points and then use the 2 lines that I created as the legs of the triangle and the diagonal that's between the 2 points as the hypotenuse and plug the values into the Pythagorean theorem and find the length of the hypotenuse. So the distance formula is a rearranged version of the Pythagorean theorem where you take an x coordinate minus another x coordinate and square it. And you take a y coordinate and another y coordinate and you square those. Kind of same elements. Oh, you don't add them, you subtract. Okay. So you take the difference in the x's and you square it. You take the difference in the y's, you square it. You add those 2 together and you take the square root of the entire thing, which is really the steps of the Pythagorean theorem, just in a different arrangement. So you only need the name of 2 different coordinates that are part of this circle to be able to then find the distance. Well, we already know the distance is 4. We already know we want our distance, our d, to equal 4. We also know that the coordinate that's coordinate 1, or is in the center, is 2, -3. What are some other ways that I can simplify this equation to try to get, I don't know, just to simplify this equation, to make it easier to interpret? What's going to happen with this minus -3?
Square root and squares.
What do you said add the square root in squares?
No, cancel them out.
Oh, okay. So let's say I want to cancel out the square root first. What do you have to do to get rid of a square root? What's the inverse operation of a square root?
Square.
A square. So we're going to take this whole side and square it, which really is just going to get rid of the square root, and we're going to square this 4 because whatever we do, if we do on both sides, then it's still balanced. So we'd have a 16 over here, and over here we would have x minus 2 squared plus y plus 3 squared. I made minus into a plus, right? You guys are all aware of that integer rule, I'm sure.